So in this example, I'm going to show you how to find wronskian of a couple of functions. For that, we need to determine the determinant. So for a 2 by 2, let's say we have a determinant A of some matrix, let's say A, B, C, D. Okay, so it's a 2 by 2, so that will just A times D minus C times B. Okay, that's easy. Let's go for a 3 by 3 determinant. Let's say that's B, A, B, C, D, E, F, G, H, I. In class I showed you just like cross product, but the most general method would be as follows. Okay, so you want to take you can expand along any row. I mean, there are 3 rows, or any column. So let's take the first column. Okay, so expand along first column. Okay, that means we write A, that I don't A. Now delete the row containing A and column containing A. Okay, so let me use this, cancel this one for a moment. Then we have now we have a 2 by 2 determinant E, F, H, I. Now we are going along this column, so next D. So the sign will be plus, minus, plus, minus. Don't ask me why, you learned that in linear algebra, but go start from always plus, minus, and so on. Okay, now the second D, plus, minus D. Now like previous, just delete the row containing D and column containing D, so you have a determinant of B, C, H, I. So B, C, H, I. And in the same way, plus G, you delete the row and column containing G, so B, C, E, F. B, C, E, F. In fact, this is called minor of this entry, and with plus sign it's called cofactor. That's linear algebra. You will be safe. Just go from plus, minus, and so on, and expand along the first column all the time. Okay, now it's a 2 by 2 matrix in each term, so you know how to find these from the previous one. Okay, let's go for 4 by 4 determinant. Let's say C equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay, it's a 4 by 4 determinant. So as usual, we wanna expand along first column. So A, now we delete the row containing A and column containing A, so we'll have a 3 by 3 determinant of F, G, H, J, K, L, N, O, P, plus, now second, minus E, delete the row containing E and column, so B, C, D, J, K, L, N, O, P, plus, minus, plus I, and you'll have a 3 by 3, and minus M, plus, minus, M, and you have 3 by 3. These plus, minus are due to their positions. Okay, now but when you are actually computing the determinant, some of these entries will be 0, so you don't have to do everything. So once you get down here, now you need to evaluate the determinant of this 3 by 3 matrix. I mean, just find the determinant using the previous method, so it will be long again. It will be another long, but let me do a couple of examples. Okay, so find the wronskian of, let's say, cosine T and sine T. Okay, so in this case wronskian will be in first row we write down the functions sine, cosine and sine. Now we're gonna find the derivative, first derivative. So cosine negative sine, sine cosine. It's a 2 by 2. So for two functions we make a 2 by 2 determinant. Okay, cosine times cosine, so cosine square t minus negative sine t times sine t, negative sine square t, that negative makes minus, plus sine square t, and we can simplify sine square t plus cosine square plus sine square is equal to 1. Okay, let me do another example, number 2. Let's find the wronskian of 1 et and e minus t. Okay, so three functions, so we have to make a 3 by 3 determinant. So in this case the wronskian will be 1 et e to the negative t. In second row we find their derivatives. So derivative 1 is 0, derivative of et is et, derivative of e to the negative t, negative e to the negative t. Now find the derivative of second row in the third row. So 0, et is et, here is negative and minus positive e to the negative t. So it's a 3 by 3 determinant now. So we want to expand along first column because it contains a lot of zeros. So 1, this plus, minus, plus. In fact, we don't have to expand along second entry and third entry. It's going to be 0. So 1, and then we'll have a 2 by 2 matrix. Delete the row containing 1 and column containing 1. So et minus e negative t and et e negative t minus second entry 0. So 0 times any number 0 plus third entry is 0, so it will be 0. So we don't need to show this one. Okay, now just find this 2 by 2 determinant. So 1 is nothing, et times e minus t, that will be just 1 minus this one times this negative, so positive, that one times that one is also 1, so it will be 2. Okay, let's find a wronskian of 4 functions. Let's say wronskian of 1 t, et and e to the negative t. Okay, that will be in first row we write down the given 4 function 1 t, et, e to the negative t. In the second row let's find their derivatives. So 0, 1, e to the t is same thing, minus e to the negative t. In the third row we write down the derivatives of second row. So 0, derivative 1 is 0, e to the t, minus and negative is positive e to the negative t. And finally in the fourth row find the derivatives. So 0, 0, et minus e to the negative t. And as usual we want to expand along first column. Yeah, you can go along first row, but that's more work because the first column contains a lot of zeros, so all we have to do is expand along first entry. So 1, now we delete the row and column containing 1, so write down the remaining 3 by 3 determinants. So 1 et minus e to the negative t, 0 e to the t, e to the negative t, 0 e to the t minus e to the negative t. Okay, we need to evaluate this 3 by 3 determinant. So when first one minus 0 times, so everything will be 0. When we evaluate this 3 by 3 determinant, again let's go along the first column because we have all we have to do is for first entry, we don't have to do for 0. So 1, nothing, 1, that's nothing, so we'll have 1 and 1, just 1, don't have to write. So first row, first column, so you'll have a 2 by 2 determinant, and you know how to find that. Okay, so it will be just it's gone. So e to the t, e to the negative t, e to the t minus e to the negative t, and you write that down.